Hi, my name is Nikhil, and this is my video for Homework 5. Since my computer couldn't handle running both Gazebo and a screen recorder at the same time, decided to, as a workaround, I'm just using my phone to record the screen. So the strategy that the robot uses here is it goes forward until there's a wall, and then proceeds to follow that wall until it reaches a hallway. When it reaches a hallway, it reorients to face a goal. That reorienting works regardless of what hallway we're in. So if we're in a hallway before the goal, we'll reorient to face north. If we're in hallway number 12, we'll reorient to face south. Now, once we've reoriented to face the target, then we'll go ahead once more to find a wall. Once we've found a wall, we'll wall follow and then repeat this process. The one thing that's different is the first time we follow to the left. The next time we wall follow, we go to the right. Then we go to the left, then we go back to the right. We keep alternating this process, which allows us to make sure that we're going to get to the goal. This also handles cases where there are loops, for example, because we'll follow the wall and we'll go in one direction. Then when we exit the wall and reorient, then we're going to follow in the opposite direction. Additionally, despite the robot not having a publicly available position, we estimate our position by kind of making a guess of what hallway we're in. This is done by measuring the number of times that we send the go forward command. I just did some initial calibration and to get an idea for what the mapping looks like for a number of go forward commands for actual corridor measurements. Looks like every roughly like 70 to 80 go forward commands results in one corridor of movement. Additionally, I subtract this value if the robot is going backwards. The way the wall following works is it tries to maintain a specific distance away from the wall. If we're too close to the wall, we'll turn away from the wall. If we're too far from the wall, we'll turn closer to 1. If we're just the right distance, we're going to go forward. This is adapted from Professor Tuck's code. Additionally, the way the reorienting works, it's a modified proportional controller where we keep turning until our pose, based off of the universal pose sensor, is aligned with 0 degrees or 180 degrees. We can see here the robot has made its way about halfway through the course. It was important to make sure that we kept track of hallways, not just by when we had finished wall following, but by using this proportional controller. Basing it based off of the number of forward commands that were sent. This is precisely because for long hallways like this, where there's no clear way to make a distinction between hallways other than just using how long the road has gone forward. We can see here the robot is nearing a loop where it'll go forward and take the wrong direction to follow the wall. The program is robust enough that we'll go ahead and follow the wall in the incorrect direction, go around this loop, and then we'll try again and we'll follow the wall in the opposite direction. In this way, we're able to escape this loop and proceed further towards the target. can see here the robot is approaching a hallway on the final corridor. So since the robot is keeping track of its position, it knows that it's in the final corridor. As a result, when it implements the reorient method to face the target, it's going to face downwards as opposed to forwards. Once it is reoriented to face reoriented to face the target and gone into the 11th corridor, it executes a separate script to center itself within the track. It centers itself using its pose estimator, and then it turns right and sweeps across to get to the target. You can see here the robot is approaching the goal and exited. It finished, and we have reached the target. If it had not found the goal in the rightward sweep, it would then do the same thing in the left.